Welcome to Shanti-Peace for Mathematics. In this video lecture, we are going to discuss about some examples of spheres. Let me start with the first example. The question is find the radius and the center of the sphere x square plus y square plus z square minus 2x plus 4y minus 6z is equal to 0. Before solving this example, I like to say that those who has not gone through my previous video lecture, that is on results on sphere, they must go through with that video lecture and then you can come back with this video, because the theory portion or whatever the results I need to discuss those examples, all the results I have discussed in the previous video, the link for that video you can found into the I button. You can go and check and go through with that video and then come back to this video. So here the question is to calculate what is the radius and the center of this sphere. So you know that the general equation of the sphere can be represented as x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. If you compare this equation with this, you will have a 2u equal to minus 2, 2v will be 4, 2w is minus 6 and d will be 0. So that will give you u will be minus 1, v will be 2, w is minus 3 and d will be 0. So hence the radius, we know it is the square root of u square plus v square plus w square minus d, which will be 1 plus 4 plus 9 minus 0. So that is square root of 14, and the center is minus u minus v minus w, which will be minus minus plus 1 minus 2 minus minus plus 3. So 1 minus 2 3 is the center for this sphere you will have. Let's have the next example. The question is to obtain the equation of the sphere described on the joining of the point A equal to 2 minus 3 4 and B equal to minus 5 6 minus 7 as a diameter. Let us try to solve this question. First of all, what is this question is given? Suppose this is the sphere, this is the 3-dimension object, and the extreme point of the diameter is given, that is A, which is 2 minus 3 4, and the B, which is minus 5 6 minus 7. As you have seen that the extreme point as a diameter is given, the equation of the sphere can be represented as x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. This is the formation, or this is the way the equation of the sphere whose extreme point as a diameter is given as x1 y1 z1 and x2 y2 z2. Now by just need to substitute these values of x1 y1 z1 and x2 y2 z2 here. So that will give you x minus 2, x plus 5, y minus, instead of y1 we have minus 3, so it is plus 3, y minus 6 plus z minus 4, z plus 7 equal to 0. So we can simplify. This is x square minus 2x plus 5x minus 10 plus y square plus 3y minus 6y minus 18 plus z square plus 7z minus 4z minus 28 equal to 0. Further you simplify this, then that will give you x square plus y square plus z square minus 2x minus 6y plus 7z, and the constant term is minus 10, minus 18, and minus 128, which is 56. So that is gives you minus 56 is equal to 0. So this is the required equation of the circle, which having the extreme point as this A and B. Let's solve this next example. The question is, find the equation of the sphere through the point 0, 0, 0, 0, 1, minus 1, minus 1, 2, 0, and 1, 2, 3. So here the question is to calculate the equation of the sphere passing from 4 points, and these 4 points are given as this way. So we know that the in general equation of the sphere is of the form x square plus y square plus z square plus 2ux plus 2by plus 2wz plus d equal to 0. In general equation of the sphere can be represented in this way. Suppose this sphere is passing through this 4 points. That means this sphere must satisfy, this equation of the sphere must satisfy this 4 points. So that means if I put at t equal to, at 0, 0, 0, that means if I put x is equal to 0, y equal to 0, and z equal to 0 into this equation, then will gives you d equal to 0. At point 0, 1, minus 1, if I substitute this value into this equation, then it is 2, because 0, so x is 0, y is y square, that is 1 square minus 1 square, so that's why it is 2 plus 2u into 0 plus 2v minus 2w plus d equal to 0. So that will implies 2u minus 2w, and the value of d is already 0, plus 2 equal to 0. So that is the quantity we got at point minus 1, 2, 0. Let's see what we get here. So x square is there, so it is 1 plus 4 plus z is 0 plus 2u into minus 1 plus 2v into 2 plus 2wz into 0 plus d is already 0. So that gives you 4v minus 2u plus 5 equal to 0. That is the second equation we have. So in the third point, that is 1, 2 and 3, if I substitute, then at the point 1, 2, 3, then it is 1 square, that is 1, 2 square, so it is 4, 3 square, so it is 9, then it is 2u1, 2v2, 2wz, that is 3 plus d equal to 0. So this will gives you 14 plus 2u plus 4v plus 6w equal to 0. So finally now we have 3 equations. Let me write all these 3 equations here. The 3 equations are this, that is 2v minus 2w plus 2 equal to 0. The another one is minus 2u plus 4v plus 5 equal to 0. Now that is the equation 1, 2 and 3. Now we have to solve this 3 equation, and we can find out what will be the value of u, v and w. That is the 3 linear equation, and that 3 linear equation can be easily solved using by substitution method or in matrix algebra method, whatever way you can able to do that. Try to find out what will be the solution for this 3 equation. For example, I can take the value of v and substitute here that value of v, that will gives me equation in w and so on. So you can do that procedure, and we got the value of u is minus 15 upon 14, v will be minus 25 upon 14, and w we have minus 11 upon 14. That you can verify and check, and already we have the value of d, which is 0. So since we have this value of u, v and w and d, we can have now the equation of the sphere by putting the value of u, v, w and d into this equation. So that's why the equation of the sphere will give you x square plus y square plus z square minus 15 upon 7x minus 25 upon 7y minus 11 upon 7z equal to 0, which is the required equation of the sphere we have. Let's solve the next example. So prove that the sphere x square plus y square plus z square plus 4x minus 6y plus 2z minus 86 is equal to 0 and x square plus y square plus z square minus 20x minus 36y plus 30z plus 424 equal to 0 touch each other externally. That means we have to prove that these two spheres, let's say this is the first sphere and there is another sphere and both of them are touching each other externally, that we have to prove here. So I am trying to draw that figure as visualization. So this is another sphere that you have and they are touching externally. So suppose that this is the center and ultimately what we need to prove is that the distance between C1 C2 is equal to R1 plus R2, because that is the objective of proving this thing. So for that I need to calculate what will be the distance between C1 and C2 and what will be the radius of both the sphere. So I may call this is as a first sphere and this is as a second sphere. Let me calculate what are the radius and the center for the first sphere. So I just give the title for sphere 1. If you compare the sphere 1 with the equation x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 equal to 0, we'll have 2u1 will be 4, 2v1 will be minus 6, 2w1 will be 2 and d1 is minus 86. That you will get from this coefficient. So u1 will be 2, v1 will be minus 3, w1 is 1 and d1 is also minus 86. So hence from this we can get the radius. I may call it that is as R1, which is the square root of u1 square plus v1 square plus w1 square minus d. So that will gives you 4 plus 9 plus 1 plus 86. So it is 4 plus 9 plus 1 plus 86 and that is gives you 14 plus 86. 14 plus 86 will be 100. So that is 10. And the center I may call it as C1, which is minus u1 minus v1 minus w1, which I can say that this in the u1 is 2, v1 is minus 3, 1, so it is minus 2, 3, 1, minus 1. So it is minus 2, 3, minus 1. So this is your v1 and c1, r1 and c1. Now let me calculate for sphere 2. So comparing the sphere 2 with x square plus y square plus z square plus 2 u2x plus 2 v2y plus 2w2z plus d2 equal to 0, you will have 2u2 will be, to compare with this equation, that is minus 20. So that is minus 20 minus 2v2 will be minus 36 and 2w2 will be 30 and d2 is 424. So u2 will be minus 10, v2 will be minus plus 18 and w2, sorry, this is minus 18 and w2 is 15 and d2 is 424 that we already have. So this radius of this sphere, that is R2, will be square root of u2 square plus v2 square plus w2 square minus d. So it is 100 plus 18 square, that is 324, plus 15 square, that is 225, minus 424. And you can simplify this, that will gives you 225, and the square root of 225 is 15, so that's why the R2 is 15. The center we'll have it is minus U minus U2 minus V2 minus W2, so that's why it is 10, 18 and 15, minus 15. Now let me calculate what will be the C1, C2. C1, C2 is the distance between these 2 points, that is square root of, we can have minus 2, minus 10, minus 2, plus 10, square plus minus 18, minus 3, square plus 15 plus 1, 16 square. And you can check that this is nothing but the 25. And R1 plus R2 also we have 10 plus 20, 15, which is 25. So therefore C1, C2 is exactly same as R1 plus R2. So hence we can say that these two spheres are touched externally. Next example says that prove that sphere square plus y square plus z square minus 2x plus 4y plus 4z minus 16 equal to 0, and the plane 2x minus y plus 2z equal to 12 intersect each other, and find the radius of the intersecting circle. So let us try to solve this equation. So here the given equation is x square plus y square plus z square minus 2x plus 4y plus 4z minus 16. Let us try to calculate first of all what is the center of this sphere. So to comparing this equation with the standard equation, that is will gives you 2u equal to minus 2. So u will be minus 1. 2v equal to 4, so v will be 2, and 2w equal to 4, so w will be 2, and the value of v is minus 16. And what is the situation is given here? Here there is one sphere is there, and we have to prove that this sphere is intersecting this plane. That means there is one plane is here, and the sphere and this plane are intersecting each other. We have to prove that, or we need to find out this intersecting circle, that we know that the intersection between a sphere and a plane gives you a circle, and this is intersecting this circle. What is this radius of this circle? That we need to calculate. So we know that the condition for intersecting the sphere and a plane, it is c bar dot n bar minus p upon mode of n bar. If it is less than the radius, then we can say that the sphere and a plane is intersecting. Now what is this c bar dot n bar minus p upon n bar? It is actually this distance from center to this plane, and that can be calculated using this. What is c bar? That is the center, that we have minus u minus v minus w, so that is gives you 1 minus 2 minus 2. What is n bar? It is the normal to this plane. The normal to the plane can be calculated using this coefficients, that is 2 minus 1 2, that is n bar. What is the value of p? It is this, and that is minus 12, because if you can take 12 on the other side, this will give you minus 12. So this is the value of c bar, n bar and p bar. So we can calculate this, what is the value of this cm. So let us calculate the value of cm, which is c bar dot n bar minus p upon mode of n bar. We know that the c bar is 1 minus 2 minus 2, dot n bar is 2 minus 1 2 minus p, which is minus 12, upon n bar square mode of n bar, that is 1 plus 4 plus 4. So it is 4 square plus 1 square plus 4 square. So that we have written. And if you can simplify, this is 2 minus plus 2 minus 4 minus plus 12. And the mode of this upon square root of 9, which is 3. And if you can simplify, this is 4 will cancel out, so it is 12 upon 3 and which will give you 4. So, and the radius, that is the square root of u square plus v square plus w square minus d, which gives you, in the previously we have calculated u, v, w and d also. So it is 1 plus 4 plus 4, which is 9, and plus 16, so it is 25 and will give you 5. So we can say that this cm is smaller than r, because the value of cm is 4 and the r is 5. So therefore we can say that this sphere touched, this plane and this plane are intersect each other. And what will be the radius of this? The radius can be calculated, what is the radius of the circle can be calculated using this formula r square minus p square. What is r square is this? That is a 25 square, and the p square, not p square, but it is actually, that is r square minus cm square. R square is 25 minus cm square, that is 16, which is square root of 9, and that is 3. How we can get this formula? We can just see in the previous slide. See, this is the, let's say this is the point P we know the value of cm. The value of cm is this value which we have here. And what is Cp? Cp is the radius of the sphere. So I want to calculate what is MP, which is by Pythagoras theorem into the triangle CMP, that is Cp square will be Cm square plus MP square, and I want the value of MP, that is MP square will be Cp square minus Cm. So it is, we got, as we have 25 square, that is r square minus Cm square, that is 25 minus 16 equal to this 3. So the radius of that sphere will be 3. Let us solve further more examples. So let me write this example. If the sphere x square plus y square plus z square minus 2x plus 2ay plus 4z minus 16 equal to 0, and the plane ax plus y plus 2z plus 19 equal to 0 is touch each other, and the value of, let us try to solve this example. What is the situation? They say that this plane and this sphere, they are touch each other. That means the situation is like this. This is this given sphere and this is the given plane. And the thing is, this two sphere and the plane are touch each other. So this is the intersecting point. That means if you draw a perpendicular distance from this point or a center to this plane, it will be exactly the same as the radius. That is the situation we have. So let me calculate what is the radius and what is the center of this sphere. So if I compare with this equation with the standard equation, that is gives you 2u will be minus 2, 2v will be 2a, and 2w will be 4. So u is minus 1, v is a, and w will be 2. So therefore the radius you will have, it is u square, that is 1 plus v square, that is a square, plus 4 minus, and d, the value of d is minus 16. So minus minus plus 16. So that's why this will give you 4a square plus 21. This is the value of radius, and the center will be minus u minus v minus w. So that will be 1 minus a minus 2. So this is the value of center and the radius. Now we know the formula, that how to calculate the perpendicular distance from the point to the plane. The formula is this. Suppose this is the plane ax plus by plus cz plus d equal to 0, and there is a point x1, y1, z1, then the formula to calculate the distance between these 2 points, generally it is denoted by a small p, which is ax1 plus by1 plus cz1 plus d upon square root of a square plus b square plus c square. This is the distance between point. This is the formula to calculate the distance between this point and this plane. Here we have also the same thing. I need to calculate what will be the distance between the center and the given plane, and that is exactly same as the radius. That is the situation we have given. So let us calculate first of all what is this distance is. So what is the distance? That is, what is the plane equation of the plane is given to. Let me write down ax plus y plus 2z plus 19 equal to 0. This is the equation of the plane, and the center we have calculated, it is 1 minus a minus 2. So that's why this distance between these two is a into 1 minus a minus 2 into 2 plus 19 upon square root of a square plus 1 plus 4. So this will gives you, this a will get cancelled out. So we will have 19 minus 4, that is 15 upon square root of a square plus 5. And the value of this distance is exactly the same as the radius. So that's why the p equal to r, and this will gives you 15 upon square root of a square plus 5 is exactly same as square root of a square plus 21. So this will gives you 15 into a square plus 21 into a square plus 5. So if you simplify this, this will gives you 15 equal to a square plus 5 a square plus 21 a square, and 21 into 5 will gives you 5 105 plus 105. So this will gives you a power 4 plus 26 a square minus 15 square is there. Here it is 15 square. So this is 256, 225. So 225 minus 105 will gives you 120. So this is minus 120 equal to 0. So hence, if you can factorize this, which factorize into a square plus 30 and a square minus 4 equal to 0. But a square will plus 30 will not be 0, never be 0. So a square is, because a square plus 30 is not equal to 0. So a square, the value of a is 2 or plus or minus 2. So the value of a, that is the question was to calculate, find the value of a. So the value of a we got, it is plus or minus 2. Let us solve some couple of example more. The question is, find the value of a and b. The equation of the sphere having center a b minus 3. So this is the center is given, and passing through circle x square plus y square plus z square minus 2x plus 4y plus 4z minus 16 equal to 0, and 2x minus y plus 2z equal to 12. Also find radius of the sphere. This is the situation is given to us. We need to calculate the value of AB and also the radius of the sphere. The equation of the sphere having the center is this. So center of that sphere is given, and which is passing through this circle. As I have talked in the previous lecture, the equation of the circle is also always in R3 will having the pair. So here they have one sphere is given and one plane is given. So intersection between this sphere and a plane gives you one circle, and passing through that circle there is a required sphere is there, and having the center is this point. So we know that the equation of the sphere passing through this circle can be represented as x square plus y square plus z square minus 2x plus 4y plus 4z minus 16 plus lambda 2x minus y plus 2z minus 12 equal to 0. So the equation of the required sphere is this. So if we can simplify this one further, then we can have the coefficient of x as minus 2 into 1 minus lambda x, minus of minus 4 plus lambda y, minus 2 into minus 2 minus lambda z, minus 16 minus 12 lambda equal to 0. Now, to compare this equation, what is the what is the center of this sphere? You know that if you compare with x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus v equal to 0. If you compare this equation with this, you will 2u is 2 into 1 minus lambda minus 2 into 1 minus lambda. 2v is minus of minus 4 plus lambda. 2w is minus 2 into minus 2 minus lambda, and d is minus 16 minus 12 lambda. This will gives you u equal to minus of 1 minus lambda. V will be minus of 2 plus lambda by 2. W will be minus 2 minus lambda, and the value of d, which we already have, that is minus 16 plus lambda. The center of this sphere is minus 2 minus u minus v minus w. According to this, which will have 1 minus lambda, minus 2 plus lambda by 2, minus 2 minus lambda, because that minus 2 minus lambda is already there. Hence, and also given that the center of the sphere has to be a, b minus 3. So that will give you a is 1 minus lambda, b is minus 2 plus lambda by 2, and c will be, that is minus 3 equal to minus 2 minus lambda. So this will implies lambda will be 1. If lambda is 1, if I substitute here, this will give you a is 0 and b will be minus 2 plus 1 by 2. So that is a minus 3 by 2. So the value of a is 0, b is minus 3 by 2. And if we can substitute that is into the radius, that is under root of u square plus v square plus w square minus b. The u square is exactly a, which is 0 square. V square is b, that is 9 by 4, plus w square, which is square of 3, which is 9, minus d, the value of d, if lambda is 1, that is minus 28, because minus 16 plus 12, 16 plus 12 is 28, so it is minus 28, but it is plus 28. So this will gives you, the value will be square root of 157 upon 2. That by simplification you can have, this is the radius of the sphere. So this is the example, and